You mind emailing that to me? Let's work on other things some more. Unless other people have questions. Okay. Can y'all hear me out there in Zoom land? Yay, that's a good thing. All right, let me see if I can figure out how to apparently is the video on me? Because I can't see if it is.
Yeah.
Okay. Well, I'm gonna have to adjust my cameras because I can't see that at all. How about view? I'll go with the Brady Bunch view. Go to my school email, please. Maybe if I switch host, maybe that'll try that. Claim host. Interesting. Okay, I know why. Because it's on that screen. I was like, why am I not visible? Let's try this. We had two views of John in Ponca City. Okay, well, welcome to Experimental. We have hit the October day, and I think our last progress report is due today, if I'm right. Let me make sure it's out and functional for you all. Make sure it's up there. So I did get a chance to grade not very many, just a few of those, but I'm hopeful to grade those coming up very soon. Let's see. Courses, experimental, and progress reports. Yep, number 4 is out there. So make sure you take some time to get your 25 points and make sure that it's all good for you. That way you're not just leaving points hanging out there and not getting credit for them. Let me do a check-in. Who now has closed their surveys? Raise your hand if you closed yours. Oh my gosh, everybody in Alva. I've got John closed. I got half of Woodward. How about Enid? Did y'all close your surveys yet? Cam, you closed yours? Okay. All right. So we are ready to move forward then. And if you haven't, don't panic. It's okay. I'm gonna, checklists help. Checklists help because that way you go down and just, hey, did I do this? Did I do this? Did I do this? Especially if, it's been a while since you've had stats and you've never really applied stats before. My point for this class today is to help you understand your stats that you're running. So we're going to do two things. We're going to take a look at the surveys that you all have compiled. And where stats start to make sense is when you look for violation of assumptions. And we'll talk more about that in just a minute. But so you'll get a chance to look and see how you run these things in SPSS. Well, we're getting close. When did I say we should download SPSS? Was it next week? I think so too. I think we need to get, if you're going to go for the 2-week free, I think let's do it next week because we're past like 50% of us. And I know a survey just went out today, and if you haven't taken it, please take it to help a fellow sister out to get this thing done. So yeah, stats never really made sense to me. Well, I'll say numbers in general. I didn't like algebra. I didn't like geometry. Wasn't really a big fan of math until I got to psychology. That's odd. Why? Because you went to psychology, right? Because you sucked at math. And it was kind of that thing for me. It was kind of like most of you, like back in the day. Hey, my math scores aren't that great. I really think it's boring. I really like psychology. I think this is a cool subject. Like I've never heard anything like this before. Like we're talking about people. I'm pretty good at writing, so I can handle that. So I was like, yeah, I'll do psychology. What a major, right? So I get into it, and then I'm all dreading this stats class. Like, golly. And then my professor, oh my gosh, I didn't bring my book. Oh, hold on. I think I did. Oh, if I didn't bring it, I'm gonna kick myself. I'm gonna kick myself if I didn't bring it today. My professor just made it fun. It was completely applied the whole time. So my stats class was not like, yeah, I had to figure out standard deviation on a Texas Instrument calculator, which sucked because it was like this formula and you do all this like by hand. That sucked a lot. I didn't enjoy that, but I did enjoy then on the end of it, it was like, oh, like I get why this is important. I get where this is going. And this like somebody like screwed that light bulb in for me and I started getting numbers and I started getting stats. I'm still not the best, but I can make my way through some statistics now. So I want you to understand why and what it is that you're putting together. We're going to use some visuals to help you see what we're doing. All right, so progress report number 4, don't forget that. Let me start with housekeeping. Does anybody have like questions, concerns, things that we need to address before I get into like the nuts and bolts of the ideas for today? Okay, don't everybody talk at once. All right, let's go ahead and I want to work on the data we started with. That was on Tuesday. And so y'all have kind of made some updates, is that right? Could do some coding updates. Let's dive into this. We're going to check for a couple of things, maybe 3 things here. So with their data, I'm excited to see it because when you see their data, you'll see like, because I just ran those preliminary stats on Tuesday. You'll see like, oh, that's what this is. That's why we do this. You'll also see like how you use the SPSS program. So if you're like, most of you are gonna be like, it's okay. Next week we'll come in, we'll get into this and we'll start running some numbers, getting some graphs, and we'll start writing our results and get this thing, hey, this huge project for a whole year, we'll get this thing behind us. Okay. You sent me an email, right? Okay. Let me see if I can find it. There, maybe here. Oh man, I'm getting emails left and right. Two came in after you. I get so many emails per day. It's ridiculous. So you sent this to my student or my professor. Okay. Thing. Oh, sure. Don't ever go anywhere without your cell phone. So double validation. God forbid. Oh, don't steal my code.
Right. This is so annoying. I cannot stand those.
Don't share that. Don't share your code. I'm going to use it for like 2 minutes.
Right.
Okay, so here's their data. Let me go ahead and download it so it's easier to work with. So I'm going to download it. Let me first off close what I had. There we go. Create a copy, download copy. There it is. I want to get out of this. Hold on. Hold on just a moment. Sorry. I just want to close this. All right, I have to start it over again. Oh, here we go. Nope, I don't want to save that one. Stop. Just let me exit. Okay, so you all have coded. What I can tell is that you've changed these words into numbers. So if y'all are working on this, I've created a cheat sheet that I will put up for everybody. I love the checklist. And I'm trying to create a good, clean one for everybody. My checklist may be a little bit different, but this one I like. Control A, get this a little bit bigger. Okay, so when we're running our steps for running statistics, this is a good place to start. The very first place to start when you, oh, thank you. Paige, I appreciate that so much. The very first place to start is to go back to your research questions. Where are your research questions in your paper? They're in a very specific place. Should be.
It's gonna be in your hypothesis or when you're going through there.
Yeah, it should be right at the end of your lit review, right? Your research questions. Okay. Make sure you always have those handy. I can't tell you the amount of time that I was in the middle of a spreadsheet in my dissertation and like, why am I even doing this? Go back to your research question and it'll tell you what you're supposed to do. Because a lot like y'all three, y'all have a lot of like data. That's okay. You do too. That's okay. Go back to your research questions. You ever get lost, go back to your research questions. Why am I doing this again? And then what questions are you trying to answer? Is it a question of relationship? How does one variable relate to another? Does one variable predict another variable? Do you have questions of how much? Do you have questions, is this significantly different from something else? Do you have questions of difference? How you ask the question directly determines the stats that you're going to run. Directly. So again, please have your research questions ready to consult as you run your stats. Consult your appendices. We talked about this last time. Make sure that you have your instruments. Make sure that you have your actual questions. I mentioned if you can have it on no more than one screen. If you don't have that, hey, I've only got a laptop, Dr. Randolph, this is all I got. I'd say even go print your survey where you can consult it like while I mean, it's really important if you can see it as you're working on what it is. So it really helps. Otherwise, you get interrupted. You're like in between screens. It's a mess. So yeah, if you can have a copy alongside when you're running your stats. Then what this group just did, code your data. Go through and convert data that is worded to numbers. That's what their task was for today, and I think they've achieved that. Keep your own guide to your coding. Like I showed with my chicken scratch, which is really hard to read. Just make sure, yeah, you got it. All right, good. So that way you can go back and say, what did I do again? Male was 1, female was 2, or is it vice versa? Write it down. Okay, you need to know what your numbers mean. Reverse code when necessary. In other words, if it's an inverted question, like Cam said, you need to maybe flip your numbers around. Keep that. That's because if you don't do it, it makes everything invalid. Now, finally, what stats are you going to run? Again, consult your research questions. They directly determine the stats you're going to run. All right. Then, very next thing, we're going to check for violations of assumptions. Let's do that with theirs because that's kind of a new concept. We haven't really jumped into violations of assumptions. When you run your stats, who here has heard of the concept of an outlier? From stats, what is an outlier in your words?
It's something that significantly or statistically doesn't line up with the overall numbers, where it's on its own, kind of on a little island over there.
It is. It's a number that's kind of on its own little island. So there's an assumption for most statistics, and it's the assumption of, there are several ways of saying it. A normal curve, a bell curve, a Gaussian curve. What does that mean? If we assume that the data is going to be looking like a bell or a bell curve? Yeah, now that's okay. If you don't have it, that's okay. That's why we're doing this. That's why we're doing this. We're going to check for that first, and there's a way to do that. So here's their survey. Let's go ahead and import it into SPSS. Let's go ahead and move it on over because there are very good tools in SPSS to help us check this. All right, what did you see there? What is this what right here even as SPSS opens up? What are y'all seeing here? Kind of looks like a curve, like bell curve, this distribution. This is fundamental to most statistics, is that you assume that data is here in the form of a bell curve. Let me see if I can do a really quick recap for everybody of stats. Get a tabula rasa, a blank slate. Okay. When we start looking at graphs, when we start looking at these bell curve type shapes, we're going to also look at scatter plots. Scatter plots really show us relationships. And if you didn't get it in stats, now's the day where that stuff, where I talked about my light bulb getting screwed in, here's the day where your light bulb gets screwed in, and it's okay. So let's say that we have, let's just use IQ. IQ is a debated topic, but we have IQ tests out there like the Wechsler, like the Stanford Binet. What is the average IQ according to psychology, if you're looking at numbers? You may know that one?
Is it 100?
What's that?
100?
Yes, yes. And so the average score, and I'm going to put up, oh my goodness, come on now. This has to work. If it doesn't work, then everything is lost. Oh, please. Let's see here. Is there any way? Oh, I turned it off. I know how to do that. I can turn it off and on. Let's see here. Any like tricks anyone knows? No. That's unfortunate. Okay, well, I'm gonna roll with it. The average score, italicize M. When you have an italicized letter in your papers, it's an assumption that's representing a statistic. So when I talk about mean, you also see mean represented as an italicized X. So mean for an IQ is 100. And so I really need to be able to draw. This is not going to work out. Let me see if I can draw with my mouse somehow. Is there a draw function? Yeah. Insert. Oh yeah, here it is. Can I just like 3D model, smart art? No, I want to draw stuff. Line. I might have to go to Microsoft Paint. Oh my goodness. Sorry, I'm trying to make this happen. It's been a while since I used this. Like, this is like one of the OG Microsoft. I don't even think they have it anymore, do they?
Well, they do. They do. You may have to type it in. It may not be on your computer, but it's definitely still.
There it is.
There
it is. Yeah. Like this is an OG app. Okay. Here it is. Microsoft Paint. All right. So I just want to draw some stuff here. Okay. So let's say on this line here, on our y-axis, oh boy, here we go with geometry, x and y axes. This is our up and down axis. This represents number of people. Oh my goodness, sorry. Number of people. This is painful for me to do. All right, so this is the number of people. Oh, and that's this y-axis. The x-axis here, And we're only going to go in this direction this way. The X, so this is, this is 0. And we'll say that we're going to sample, let's say that we're going to sample 1,000 people. So we're going to give an IQ test to 1,000 people. All right. And this is how the bell curve then determines how IQ looks among 1,000 people. The shape is going to show you how this data is distributed. How many people like have 100 IQ or around 100 IQ? All right, so on this axis here, this is actually going to be the IQ score. If I can write this out, so bear with me. Again, my chicken scratch doesn't get better with the mouse. IQ score. And so here's 100. This is the average, right? The average should be right in the middle of this. Anybody know the standard deviation of IQ tests?
Plus or minus 15.
Thank you, sir. So the mean is 100. We know the standard deviation of an IQ test because they're created to have a standard deviation of 15. All right. The standard deviation is 15. Your standard deviations, each one of you will figure these statistics. Each one of you, when you get the thing that you're actually measuring, in your case, what are you all measuring? You're measuring stress, right? You're measuring stress. What are you measuring? What's one measurement? What are you measuring?
Body comparison.
Body comparison. Come back to that. Paige, what are you measuring?
Relationship quality.
Relationship quality. So there'll be a number representing relationship quality. You'll figure an average. So whatever it is that you're measuring, you'll figure an average score for all of your people. Okay, that's important. You'll also figure a standard deviation. Anybody know what that is? What that means? Oh no.
It is the total number of separation between the range or between the highest point and your lowest point, or highest accepted data point and lowest accepted data.
So you mentioned range. Range is a good thing to get in here too. So let's go ahead and put range. Range is a little bit different, but it's very important. So the range here on an IQ, I guess, would be 1 all the way up to, I don't know, what's the maximum IQ? It depends on your sample. So the range really depends on your sample. Let's say you sample like 10 people and your lowest score is an 85 and your highest score is a 115. Your range is actually only 30, between 85 and 115. I think that's 30 if you do that math. It was last time I checked. So I didn't check. Anyway, yeah, so your range is important. So you'll also figure the range, but the standard deviation is I like to use this term to describe standard deviation. It's the spread outness. It's the spread outness of the distribution. How spread out is it? It's kind of related to the range. It's kind of related to the mean, but it also relates to what you're going to see where the data is in just a minute. Okay, so let's go ahead and keep working on this. So we've got 15, and standard deviation here is plus 1. Plus 1 standard deviation is what? What would the IQ be if you had plus 1 standard deviation? Standard deviation is 15. So if you had plus 1 on the 100, it's what?
115.
115. So 1 standard deviation above the mean here is 115. All right, so let's go with like some really smart people. And let's say somebody scored a 130. How many standard deviations above the mean are they then?
2.
Yeah, they're 2. So 130, let's say we even got some really smart people in this IQ. Like we're talking Stephen Hawking range and stuff like that. So go up another, and we go 3 standard deviation. That's very rare. Plus 3. Okay, and then what would one standard deviation below be? What would that number be? 85. And then we actually have, the IQ of 70 is actually the cutoff, the official cutoff for people that would be classified as having intellectual disability or cognitive disability. So that's 2 standard deviations below the mean, and that actually qualifies somebody to get, assistance.
82 is the lowest that the government will hire you.
I didn't know that. -3, it would be 55, right? Okay. So again, now we've got IQ scores on this, so low to high. Over here, we've got number of people. So if you give 1,000 people, let's say our number, so again, imagine this being an italicized N, because if you write down N and you write down 1,000, that's your sample size. So N equals 1,000. Our sample size was 1,000 people. If you give 1,000 people an IQ test, the distribution is going to look a lot like this. What did I just draw?
Bell curve.
Which means that most people are going to score right around 100. If you look at a true normal distribution, if you go between 1 and -1 and +1 standard deviations, 68% of population will score within 1 standard deviation of the mean. What's odd about this shape with humanity and what we've noticed with statistics is if you line up everybody in this classroom and we all go on the track somewhere, we're all going to line up at the track. Okay, we're all going to sprint 100 yards. If you looked at our data starts to look like a bell. If you were going to give us, let's see here. I want to be fair in how I state these things. Let's say you give us all a math test, right? Please God, no. Now we're in psychology, so our math scores might be lower than the national average. I'm playing with you. But if you gave us all a math test, we'd score pretty much. If you put us all together and you looked at our data, it'd start to look like this. What's odd is a lot of things exist with this bell curve. And a lot of our statistics then are built on this assumption that if we give 1,000 people an IQ test, if you do the math, around 680 of them, give or take a few, because that's 68% of 1,000, around 680 of them are going to be right here. There'll be another 14% that score here. That's what this 14 stands for. Another 14% that score here. And then there'll be about 2% that are super smart. And there'll also be about 2% that are intellectually delayed or just, have an intellectual disability. So if you add all these things up, 68 plus 14 is 82. 82 plus 14 is 96. Plus 2 is 100. So it's basically, when you look at this, it's basically like somebody took a pie chart. So think about the standard, think about this bell curve as like a pie graph. A pie graph represents what percent? 100%, right? You can't have 110% on a pie. I give 100% effort, right? You can't have a pie graph with over 100%. That's it. But it's like somebody cracked an egg with, it's like easy, what is it? A sunny side up egg. You knocked it down and here it is. That's what this is. It's just represented in a different way. Okay? So when you think about it, a distribution, it's just basically where do most of the scores lie? Like if you were to put it on this, you'd say that what, 68%, that's about 68%, or plus or minus one standard deviation. That'd be the folks in here. Then you have the rest of them, you know, whatever that is, it'd be 32% over here, and that's the folks out in the tail. These are called the tails. Now, I'm gonna throw is this landing for people, right? Is this like, are y'all getting this? Is it a little bit? Like, I got some nods. Hopefully this is like, you know, going back to stats, hopefully it's making a little connection. If not, I'm glad it's making a connection today. Here's where the concept of outlier is. Let's say that we have a score on an IQ test of 1,000. Let's say that we get Stephen Hawking. I don't know what his IQ was. But let's say he has a crazy IQ of like 230. What's that going to do to the mean? Now, with 1,000 people, it's not going to affect the mean that much. But if we had 100 people, that's going to do what to the mean?
Skew
The
it,
average. What's that?
skew it.
It's gonna move. It's gonna significantly affect the mean, and that's gonna affect all of this then, because this whole thing is anchored on most of the people are centered around this mean. So if you threw an IQ, let's say we only had 100 people, and all of a sudden you throw somebody in here with a 230, that's gonna move this mean up, and it's gonna mess up our data and our statistical assumptions. Is that making sense while we're checking for outliers? Gang, I got so many nods. Yeah, this is not fun stuff, right? Until you see it and it applies to you and it applies to your data, then oh, this is math. This is why it makes sense. This is what it got is like, oh, why this is important. Yeah, it is. So, that's a really quick stats. There's one more thing I want to show you before we get in, because while I'm in lecture mode. Let me keep, if y'all want to take a picture of that, that's fine. That's all my beautiful drawing. The artistry is magnificent, and you know, you might frame that, put it up on your wall, or maybe just have it as like wallpaper on your phone. Like, wow, that's amazing. It's an amazing work of art. All right. Let's create something new. Yeah, I do want to save that. Yeah. That's a bell curve. Concepts of a bell curve. I'll put it in my Z drive. All right. Now, there's something else, and this is going to be called a scatter plot. And to me, it's easier to put out there, but it might be a little bit harder to understand. Okay? So with a scatter plot, you have the same kind of ideas. Okay? So with a scatter plot, you have a y-axis, you have an x-axis. Let's say, now, let's take a little different variable. We're not taking numbers of people now, because some of you, like your group, you're looking at stress, and what is one of your other variables that you're comparing?
Music, classical music.
Oh, classical music. That's a question of difference, and I'm not going to go there with the question of difference. Actually, I am, because you had two variables. So you had a question in there that had to do with, yeah, let's follow this concept. So they had a couple of different measures, if I remember from Tuesday's lecture. They had three questions, like, do you feel overwhelmed? Do you feel on top of things? And that was their inverted question. And how stressed do you feel? And those three, if we added those three numbers together, that came up with our overall stress rating. You had another way that you asked that question. What, you have your survey pulled up?
Yeah.
What's another way that you asked that question? Was it stress right now?
I was asked, how do you currently manage your stress?
Let's see, stress.
Oh, So right now, how overwhelmed do you feel by difficulties?
Okay, so they had these 3 questions of stress, 3 questions. Okay, and then they had another question that had, let me see how they worded it. I want this to land. We don't need any ambiguity here. Let me see if I can find it. Oh my goodness, this is horrible to try to read. You did a good job of coding because now your question, I can't tell what your questions are. And that's okay. Well, okay, so let me to move on. Let's say that we also have let's say that they also took a measurement of sadness or depression. And so let's say they gave people the PHQ-9, and so they also have a measure PHQ-9. So this is hypothetical now. And this is that's a depression score. So the higher, so on this one, if I could just bear with me, that means depression, this means stress. So now depression, so you have people on this number line, all right? And so let's now give this kind of some shape. The y-axis, here's like a score of 1, here's a score of 2, here's a score of 3, 4, 5, 6. And then their score of stress, let's say this was 5, this was 10. I don't know what, their range of scores, I don't know what it was. This is 15. Let's say for sake of argument, this went all the way up to 20. Okay. So now let's say they had 30 people in their survey. What a scatter plot does then is it puts both of these scores in relationship to each other. So let's say you had participant number 1 score a 5, and that's not, but let's say they scored a 5 on depression and then a 15 on anxiety. So participant number 1, there's a little dot here. Participant number 2, let's say they scored a 4 on depression and like a 14 on anxiety. So their little dot is going to go like right here. Let's take participant number 3, and let's say they scored really low on depression, but they really low on their stress score, so that was 5. So they had a scale that their score was here. Let's say we had participant number 4. Participant number 4 was super depressed, and they're also feeling pretty stressed, and so they scored an 18. See how I'm plotting these? I'm going here to like where it would be 18 and 6. Are you seeing where these are coming from as I'm doing this? Okay, this is a scatter plot, my friends. So to do this legitimately, the computer program will place these on a grid for you, all of your participants, and then you'll have something that looks like, let me see if I can change the font here to make this a little different. I want it to be fatter. Can I make this a little fatter? Maybe like, nah, come on. I want to show up better. Not crayon. Oh no, not that. Oh, that's it all up. Okay, well that's not working out for me. But imagine that there's a bunch of dots, and this is what we'll produce. So what do you all suspect to find? Do you suspect that there will be a relationship between depression and stress? Yes. So that's one thing that's out there in the research. There's very clearly a relationship between a relationship between higher levels of stress and higher levels of depression. So what the program then does is it tries to draw a line that best represents the average spread outness of all these numbers. So it's a little, did that click at all? And hopefully it clicked a little bit. So when you get a scatter plot, it's actually showing you if your variables are related. And it's a cool thing. So you'll put these things in your paper. So you'll put like the bell curve we produce, you'll put that in your paper. Probably produce a scatter plot. You'll put that in your paper. So you can let others know who are coming to like look at your posters on Ranger Research Day, like, oh, they got a relationship. Most of you probably will find relationships on your variables. Not everybody, and that's okay if you don't. Okay, gang, this is what we're looking at. All right, so we're gonna check for outliers now. Thanks for bearing with me. My license is gonna expire in 29 days. Y'all's not on the clock yet, but you're only gonna have 14. Okay. Let's open up their data. Let's import it. Go ahead and throw it in here, the OG copy. All right, and I'm gonna remove spaces. Here it is. The bad thing is I didn't save my work, so I'm gonna have to compute these variables again. Did you reverse code questions? I think they were 12, 13, and 14. Did you already do that or no? Okay. And so those are the questions that these are your stress. Oh yeah, you did, because there's reverse coded 9. Nice. So, and you need to add questions 8, 9, and 10 to get your stress scale. I think I'm right. So I'm going to compute a variable. I'm going to add.
I have a question. on
Yeah,
that.
yeah.
So whenever you are reverse coding stuff, do you delete the original?
No. Please don't delete the original. Leave it, because we can make the program ignore it. Okay, but because you want to go back if you make a mistake. Okay.
I have it, I just.
All right. So I didn't mean to freak out, but I kind of did.
There's also 14 and 15 that ask how stressed they feel at that moment.
Oh, that's the one that's correlated. That's what I was going to talk about. That's where I was going in my lecture, because I knew there was one that wasn't exactly. Okay. So reverse coded, let's add that one. And then let's add 10. Okay, and this is going to be stress now, or stress before, right? Stress before. Okay. And it's going to calculate it. It adds a new variable. I don't like that it's got decimals, so I'm going to go in and I'm going to tell it all the way here at the end. That's where this gets confusing. It's like, where did it go? So I've got stress before. And you've also got on question 21, you've got a question of stress after, right? All right. So what we want to do then is I'm gonna check a couple of things. So we're going to go to analyze and descriptive statistics. Each one of you, this applies to every one of you. Everyone, and so I'll need to put this on my checklist. Each one of you are going to generate descriptive statistics. And if you think about the word descriptive, that's all it's not rocket science. They're just describing, they're not doing anything fancy. They're just describing what's there. Okay. So with your descriptive statistics will come things like average, mean, standard deviation, range. These things so you're not comparing things yet. You're just throwing, hey, this is what this is. So let's look at two things. Let's explore. And it's got the thing that is called descriptive. It's been a little while since I messed with this, so I'm not going to explore quite yet. Let's go to descriptives and see what let's see what it gives us. All right. So the two things I want to look at, because these are her. Ooh, hold on. I wish SPSS did better with this. AI would do a number. Okay, so we have a numeric scale. It says here. I don't know why it calls it nominal. You guys remember our different scales of measurement from statistics: nominal, ordinal, rank order, interval ratio. Y'all have created an interval scale. There is no true zero. ratios has a true zero, but you all have created an interval scale. So that needs to be converted. Question number 21 is also a scale. Right? It's that Likert. And you guys took out number 5, right? Remember? Okay, thank goodness. Because that threw us off on Tuesday. Okay. All right, here we go. So now let's go back to analyze. Let's go to descriptive statistics. And I'm going to go to explore now because I don't. Here, frequencies. Okay, frequencies might be good. All right, frequencies. So I'm looking at question 21. And I'm also going to look at the stress before measurement. So now the statistics yes, perfect. The statistics I can find here, you want the mean, the median, the mode. You're like, oh, I remember that from stats. Not really, but you probably do. You know the names. Hopefully you don't know exactly what they are, but you know the names. Skewness and kurtosis are important in just a minute. We don't need quartiles. We do want the standard deviation, the variance, the range. Let's continue there. The charts. Let's look at a histogram, and we want to show the normal curve on the histogram. What we are doing by this, gang. Oh, I thought, no, you're good. Was that a voice?
No, it was just.
Oh, I thought I was tripping. I was like, what happened? Sorry. Okay, it's all good. What we are doing, I love that break. What we are doing is we are actually checking for violations of assumptions. This step right here, we are checking for the assumption of normality, that it's a normal bell curve. Okay? I'm gonna hypothesize something before I hit the button. I haven't done this. I'm gonna hypothesize that they're 3-question scale. I bet they get kind of a bell curve on it, and it's gonna be exciting. If this is not, then I'm gonna look like an idiot. But all right, let's try it. Let's hit it. Continue. I'm not gonna worry about format, style, or bootstrap. These are other things. I'm gonna go ahead and create APA style tables right here. Because if I do that, guess what I can do with this program? I can go ahead and drop that APA style table into my paper. Okay. So there are things that make it easy, and SPS sucks to kind of learn, but there are things that on the back end make it easy when you're doing this. All right, let's hit OK. Oh, please be a bell curve. Let's hit OK and see what happens. All right, so this is our data output. And let's just look at some of our, I know it's really small. Let me see if I can get any, I don't think I can. Nope, it's not responding. I'll just read it then. So you can see that there's 48 valid answers. You're missing 4, right? So you had 2 people so again, when I said, don't worry about the missing data, it'll track it for you. No sweat. Okay, so, and then you took out 2 because that was your own scale problem. So that's right? 48, so it's tracking it, SPS will do good. The mean is, and this is on question 21. This isn't on the other question, that's your own scale. The mean on question 21 was 1.48, that was the average. The standard deviation is 1.13, the variance is 1.26. The skewness tells me how, so I think somebody mentioned skew. So if you have, oh my gosh, I'm not even in the picture. So if you have data that's skewed, let's say this is your normal bell curve. Skewed data looks like the peak is like on one side. So it's not in the middle. Skewed data looks like this or that. That would be a skew. It's anything under 1 is good for skewness. Kurtosis tells us how peaked it is. Like a higher kurtosis number would be more like the Empire State Building. Anything under 1 is good. You want like a moderate. This is a decent kurtosis number. All right, there's the range. Okay, and this is giving you a frequency table. You don't have to do this. Oh, looky here. I've done enough of these that it just kind of emerges. It's not perfect. Your scale only has 5 questions, but you can see most people, I would say this has a slightly, this has a, I want to get it right. This has a positive skew, which means that the numbers they slope out this way. If you had most of your numbers over here on the right, it'd be a negative skew, meaning they're sloping to the negative side. Okay, so you have a slight. So if you're describing this, the researchers produced a histogram to examine and check for the violation of a normal distribution. The researchers discovered a slightly positive skew to the distribution. However, the distribution resembled a normal bell curve. All right, so you're good. I'd say this adds validity to what the statistics we're going to run. All right, now let's look at your next scale. Oh, this one's wonderful. I knew it was going to do this. I could just tell. So this is more this has more kurtosis. It's more like there's a lot of data like in the middle, making it like the Empire State Building. But it's look how that data lines up. You maybe got an outlier down here, maybe, because you don't, and maybe you've got some outliers here. So yeah, so far, what I'm seeing is we can go on with your stats. So if you had a situation where you as a researcher had, this is where you get in trouble, and you have to do. So I had this on one of my scales and I freaked out, but it was okay. So let's say that you get your data back, and all of your scores are over here on this end, and there aren't any out here. You've got a huge positive skew. There's actually a statistical way to convert that to make sense of it, where you're not lost. I had to do that in 1 month. It's okay. Where you get in more trouble is if you have a bimodal distribution. What I mean by a bimodal distribution is the mode is actually the most common occurring score. So let's say you had a bunch of people answer 2, and like 12 people answer 2, and you had like another 12 people answer 12. And then you had like this inverted bell curve. That's a bimodal distribution, and that sucks. If that's you, contact me, because it's going to be hard to work your way out of it. That's okay, but there's a way, but it's more complex. Okay, this is probably new stuff, right? You've never seen stats applied quite like this, right? It's okay. So if you want to, like on next Tuesday, if you want to be like a part of this, like I'm gonna save this and ship it to you. If you want to be a part of this, then just tell me, and we can work through this together, okay? But email me ahead of time so I have a chance to get this ready. Okay, so far so good. So what I would say is you're going to actually make a copy of this. Let's copy it as whatever it is. Copy, and then you can drop that into a Word document. Boom. And you can call that, it's not a table, it'd be a figure. Figure 1. And then you can reference that in the paper. The researchers explored, so we are exploring the data for violations of normality using histograms. The data appropriately resembled a normal distribution. Therefore, this assumption, and so I would reference, so if I were referencing that, I put table 1. And I can't remember whether it's an and, it might be an and. table 2. That'd be a good APA question, and table 2. So I'm gonna also drop in this one. This one's the more impressive one. Did y'all make these questions yourself, or did you rely on? There's a scale that you get. So most times if you can borrow a scale, like you'll get good stuff like this. All right, so I'm gonna copy that. And so good for Professor Phillips having you. And then we'll label this table 2. Oops. Okay. So you'll drop your tables in, and just like you're referencing something in your back of your paper, like in your references, you'll just reference the tables right here. That cool? Bless you. All right, let's keep going. That's it. So far so good. Let's check for outliers. So you can check for outliers using a scatter plot. I think that actually will do it for you though. Let's look at explore. Okay, so now I'm going to look for outliers. So I'm going to put in what groups did you like have groups of people that you were trying to compare?
We originally had just college students, but you mentioned that we should open it up to more than just college students.
Yeah.
So I guess we could compare college students to non-college students, but we only had a few non-college.
How many non-college students did you have?
Actually, a lot more than a few.
Ooh, it might be able to run our stats here.
17 non-students.
Then that's worthwhile. Which question or which one of these question 5? So should I take it as coding Q5? Let's do that. Let's throw that in there. All right. Now we want to go back. It won't give us the labels, but you can go back in SPSS and label. So it'll, like when you run this, I'll have it. All right. So the statistics again. Now you can see when we do this explore option, to backtrack, you go to analyze, descriptive statistics, explore. That's what brought this up. Now you can explore for outliers. Let's continue there. We can also go ahead and produce stem and leaf and histograms too. A normality test. We're gonna do some normality tests with plots. So there's actually, you know, I showed you the visual, like you can do the eyeball test to see if it's like a normal distribution. You can also run some stats. That'll tell you. So let's see if I was right in my interpretation or if the stats punch me in the face. All right, so we're gonna go ahead and produce the histograms again, and let's go. Let's see what we get. Boom. All right, so this is what we have. We had 30 people. Okay, so 1 and 3. So what so your groups are 1 and 3. So 1 would be college students and 3 would be non-college students. Perfect. Okay, so that's how their groups are. So again, you'd have a label if you put it in. So they had 33 college students, 15 non-college students. So we do want to compare these. We could compare current stress of college students versus, so you've got like all these other things you can talk about. Like I'm comparing stress between college students versus non-college students. So here's the stress before. I don't see a big difference. So here's your stress in college students was 7.42. Non-college student was 7.53. That's the average. Those are the means. Those are negligible. It's basically the same. And then here's the after. Whoa, interesting. Oh, this is good. This is going to be good. I bet you found significance. What I can see right here is that, so again, their experiment, we experienced it on Tuesday. You rate your stress. Okay, now here you listen to music. Now you rate your stress. What I'm seeing with this, just the numbers, is there's a slight difference. So like college students, their stress went from whatever that score was to 1.64. Look at the stress level in non-college students. The stress level is 1.13. I mean, they're only using like a 4-point scale. So it looks like the non-college students are actually digging the music a little bit better. This actually helped. I think so. That's going to be interesting to look at. And so now, oh wow, I did something I didn't know. I mean, we'll see. We'll see. Here's the Coleman. These are tests of normality. So remember, you can do the eyeball test with the histogram to see if it's a normal distribution. You can also have a drink called the Kolmogorov-Smirnov. Sorry, I don't know. That's they're obviously they're Russian folks that came up with these statistics. Or the Shapiro-Wilk. I myself prefer the Kolmogorov-Smirnov because it's funner to say. They're telling me the Kolmogorov-Smirnov is telling me there's some abnormal stuff going on with your distribution of college students. But your Shapiro-Wilk is saying it's no big deal. So you've got conflicting data here. I still think that's looking good. Okay, so here's your college students. I think what's going on is you have an outlier here. Somebody super low stress with your college students. But you kind of have the same thing happen here with non-college students, which is 3. You got somebody over here that's super chilled. Okay. All right, here's where you check for outliers. Actually, those low numbers are not outliers. So this is called a box and whiskers. You can kind of see the cat if you put your head sideways, like the whiskers coming off. So here's the box, here's the whiskers. I know, you gotta, that's what they call them. I took some liberties with Kolmogorov-Smirnov. 42 is an outlier, is what it's telling you here. So we might want to consider, oh, that is 2. So that is the number 2. Like I said, so up here you can kind of see it. So because there's so few people in this distribution, a 2 is considered an outlier. You had so many more people in this distribution, a 2 is not considered an outlier. Is that kind of making sense even as you look at these histograms? Because that's what the box and whiskers then is showing us, is that participant number 2 indicated they were a 2. I'm going to make an argument. And it's not a good one. Because this could explain why your score is a lot different. Remember how I said that your non-students average is lower? I think it's because there's only 15 and you got somebody that's super chilled. We're gonna have to do something with that outlier. Okay, do you see, is this making sense a little bit with the stats? If you followed the lecture, I'm hoping it is. Because like now you put all these things together and it's like, oh, now this is why we learn that stuff that was so boring. Yeah, there it is. And there's a lot of outliers for this one. And I'm not sure. Oh, that's question 21. Question 21 is problematic because it's not like multiple questions. It's just like the one. So I'm going to argue that you need to keep the questions here because you're going to eliminate a lot of your data. Okay, let's do a T. I'm fascinated because I want to see it. If we're doing things responsibly as researchers, we really need to do something with that outlier. If we make an argument to keep it, we can run a t-test. One sample, let's run an independent samples t-test. Our grouping variable is going to be question 5. And our test variable is going to be stress after. So this is where we're actually measuring if there's a difference between students that listen to the music versus non-students that listen to the music. And my groups are 1 and 3. And let's run it. Okay, Here's a t-test. So again, like we saw in the descriptive statistics, you had 33 students, their average stress score after the music was 1.64. You had 15 non-students, their average stress score after the music was 1.13. Here's your t-test. Your t-test is not significant. And here's how I know. A t-test around 2 is universally significant. When you start getting around 1.7, that's when you start seeing things being significant. Here's one-sided p. So your p value, which you're going to set at 0.05. So the probability of making a type 1 error is set rather low. You didn't hit the p value. You want to be less than 0.05. So when you all are running your statistics, and this is close though, it's 0.077. Not quite. Okay. One other thing here. Let's produce a scatter plot. And now what our scatter plot is going to be, this is for your own internal reliability. So I'm going to go to correlate. This is going to be a bivariate correlation. We're going to run a Pearson's correlation coefficient. What was the question that you asked? So you asked one singular question that asked about how do your stress level right now, correct? What question was that?
Question 14, steps before. It says right now, how overwhelmed do you feel by difficulty?
Okay, so question. Because it's kind of split up. Right now, how overwhelmed? So there's actually two. There's right now, how overwhelmed, and right now, how stressed do you feel? Okay. So that's a measuring of stress right now. So is 14 though, right? Right now, how overwhelmed by life and difficulties? Let's do this. Because those are together. Let's create our own scale, and you can do this as researchers. You can so this is question 13 and question 14. So we're adding these two numbers.
14 and 15.
Okay, thank you. 14 and 15?
Yes.
Okay. Question. Now they're both okay. Stress right now. Why didn't it change this? Hold on. That's why. Okay, this is going to be a new variable. So if we go back to this, we want to make it 0 decimals, and this is going to be a scale too. All right, so there was stress before, stress right now. What we're going to do is we're going to compare these numbers, and we're going to see if they're correlated. These were 3 questions like overall stress, right? And these are stress right now. So what would you hypothesize if we tried to correlate these together, look at a relationship? You say there's a pretty strong relationship, like, right? You'd suspect, okay? So let's go ahead and do correlation, bivariate, Pearson's, the stress before, stress right now. I might call it overall stress. Let's go ahead and hit okay. I'm going to say one-tailed. One-tailed means that you know your hypothesis. These are going to be related. All right, here's your correlation. You can see it's got a 0.73, so 73% shared relationship. Let's put that on a scatter chart. Here's your graphs, scatter plot, sorry. here's your chart builder. So I would say do this in your paper. So we're gonna create a scatter plot. And on the y-axis, again, this comes from lecture. This is stress before. Actually, let's put that on the x-axis. And the stress right now is going to be on the y-axis. What I predict is you're going to see dots in all looking like they're related, going up from left to right. Let's hit OK. And this, my friends, is your scatter plot. And if you look, you'll have dots going up from left to right. That's showing a 73% relationship. So if you drew a line, the line would be looking like this. So hopefully, I know that was a lot. It was, kind of went in the deep waters of like stats today. But we should, what I hopefully illustrated for you is that like what you did is meaningful. Like each one of the scales that you have probably will have these characteristics. If they don't freak out, don't panic, contact me and we'll talk about why. Because I want you to know that's part of the learning in this class is like, so now if you go on and you go to become graduate students, you go on to become a researcher, it's like, oh, that's why I did all this stuff. And so, we still don't quite have all your results published, but today that was not our purpose. Our purpose was to check for violations of assumptions. This is actually an assumption of linearity. So if you get into advanced statistics, there's sometimes that you assume that relationships exist between variables. That's called assumption of linearity. So, gang, thank you so much. I mean, this is I saw light bulbs coming off and on. I saw some of them were flickering, some of them maybe were still off, but that's okay. I'm hopeful that this kind of made some sense to you, and I'm hopeful that this made you a little excited to kind of step into your data and look at it. So let's plan on this. Make sure you do your assignment for today, your progress report. Make sure that gets done. Let's plan on Tuesday. Let's crank up the volume. Let's everybody get SPSS, and let's start. If you've closed, like if you haven't closed, only if you've closed and coded your data. Please make sure that you do why this was easy for us to do today is because how long did you all spend in Excel working on this? Couple hours. Because they put some effort into this ahead of time. Because if you don't put effort into it ahead of time before you move it over, it can spread out, and then those 2 weeks turn into a nightmare because now I need to really be under the gun. Otherwise, I guess the worst case scenario is you pay $35 and you get the subscription to continue. So, all right, I will share what I did with you, and so you'll be able to. And if I do your data in class, I can share the file, and SPSS will make sense on your computer. All right, everybody, have a good weekend. I'll see you Tuesday.
Dr. Randolph,
Yes.
can I sign up to have my data included in the demonstration for next Tuesday?
Yeah, go ahead. Email me.
Okay, thank you.
Prepare it as like I said. Prepare it in Excel pretty well. That's what you probably have, but we can look at it.
You actually already have mine.
Okay, and you've already got it coded and everything.
Yes, sir.
Okay, sounds good.
Thank you very much.
Yep. Yeah.
I have a question.
Yeah.
Well, two questions actually. My first question for the reverse coding,
Yes.
if they're two different scales, do you still reverse code even though they're two different scales in the survey?
Okay. So you yourself have, if I'm hearing you right, is that you have questions for one, like what are your scales names?
So like, well, one of the scales is just like a Likert scale, like
Yeah.
just regular Likert scale,
Yeah.
but the other one is the trust and satisfaction scale. So
Okay.
it's two different scales, but like the other ones, it's like, oh, how does TikTok negatively impact? Like they're acting, so 5 would be like high stress, but then the
Yes.
trust and satisfaction 5 would be, oh, you're really satisfied in your relationship.
You don't have to, and
Okay.
here's why. So, because as long as they're internally,
Yeah.
right. So you could,
Okay,
I would argue not, because you're actually going to have an inverse relationship.
okay.
So I showed a positive relationship,
Mhm.
which says as this goes up, this goes up.
Yeah.
you're gonna show a negative relationship.
Okay.
As this goes up, this goes down.
Okay,
And that's fine.
okay,
So good question.
okay, second question.
Yeah.
This is kind of like a weird question. So in my research, like when I was going through my research paper,
Yeah.
I put currently involved in a relationship for the past 6 months or whatever.
Yeah.
But then in my survey, I also have people who weren't in a relationship. Do I throw away that data because they're not in a relationship, or could I still use that
No.
data?
Kind of like what they were thinking here.
Yeah.
Let's keep it and see
Okay.
if there's something we can retain.
Because if
from it.
there's enough, because I think
Yeah.
it's like 18, so 94 people took my survey. I
Yeah.
think it's like 18 people who weren't in a relationship. But I mean, could I still use that data because that's,
Do you have, and you have like scores of like happiness or like,
well, it's more trust and satisfaction levels
Trust-
in the relationship. I guess they're not in a relationship, but it could be past relationships if they
it could be.
answered it.
keep it and we'll see what it looks like.
Okay, okay, perfect. Thank
Good-
you.
Yeah, good question.
So,
All right, let's see here. Let me save some of this stuff for y'all and email it.
Did you also post a video from today on Blackboard?
Oh yeah, let me just cancel that so it's not just getting on so long.